Hello class, Dr. Barnes here. Let's take a look at this question by finding their Fourier transforms. Okay, so first let's start with the first one, which is the unit impulse signal. So the unit impulse signal is denoted by delta of t. Okay, where t is actually equals to what? 0. Okay, and our x of t is basically equals to what? Delta of what? T. So to find the Fourier transform of delta of t, then we're going to write it like this. Okay, Fourier transform of delta of t, which is equals to minus, you write the formula for Fourier transform, which is minus infinity to infinity. Okay, x of what? X of t into e minus what? J omega omega what? T. Okay, the t. You must always remember the formula and then write it down. So here we're going to put in the value. So x of t is basically what? Delta of what? Is basically delta of t, which is multiplied by minus j omega of t dt. Okay, but before we proceed, let us draw the signal for basically the unit impulse function. So unit means that it is one, it is occurring at only one place, and unit impulse occurs at what? 0. And here this place is what? Delta of what? T, and the amplitude is always what? 1. All right, and the amplitude is always 1. Okay, so here what we can just do is that the Fourier transform for what? Delta of what? T, okay, is going to be equals to what? This one. Okay, so here our delta of t is basically what? 1. So let's just put 1 here like this. Okay, and then it's what? E minus j omega of t dt. Okay, 1 multiplied by any number is that same number, so we just remove the 1 and then just put in this one, minus j omega of t dt. Okay, and then we know that our signal is unit impulse. It's occurring at just at one specific instant of time, and that is all. Okay, so now because of that, what we can say is that it's occurring at a unit it's occurring as a unit impulse. It occurs at one specific place, and that is all. It doesn't occur at another place again. Okay, so here, even though it's Fourier transform, what happens is that we cannot have any kind of serious integration over here, because it occurs at one place, and the place is occurring at what? Is at what? 0. So now I'll put 0 in terms of what? The time. In terms of t, I'll put 0 there because it occurs only at 0. So when I do that, then it will become minus infinity minus what? Infinity. E exponent minus j omega what? Omega 0. Because it occurs only at 0. Now, because it's occurring at just 0, then I'm going to have E here like this, okay? And then, because here is 0, this whole place will become what? 0. Now, the signal occurs at only one specific instant, so it's not occurring from minus infinity to infinity. Okay, so my minus infinity to infinity here will not work at this particular place. So I must just write E exponent what? 0, which is equals to what? 1. So the Fourier transform, okay, so the Fourier transform of delta of what? T, delta of t, which is unit impulse, is actually equals to what? 1. And you can also write it in this way, that delta of what? T has a Fourier what? Has a Fourier transform of what? 1. Or you can write it vice versa. Okay, so that is our first question. That's the answer. Now let's go to the second one. So now in the second one, what we have is that delta of what? T minus what? T naught. That is also an impulse function, but this is not unit impulse. Okay, this may be like a kind of impulse train or something like that. Okay, so here what we can basically do, but here it's not really an impulse train. If it were impulse train, then it would be a number. Okay, but here it's just only at what? A time shifting, okay. T is being shifted by what? T naught. Okay, so here in this question, what we can say is that our x of what? T is actually equals to what? Delta of what? T minus what? T naught. Okay, so here T is basically equals to what? T naught. Okay, T is actually equals to T naught. Okay, and then if we should put in our formula, our Fourier transform. Okay, so let me write here Fourier transform. Okay, so Fourier transform of delta of T minus what? T naught. Okay, is going to be equals to here infinity minus infinity, okay, into x of t. And what is my x of t? My x of t is basically what I have here, delta into what? T minus what? T naught, okay, into e exponent minus j omega t d what? Dt. Okay, but here what I must know is that my function is only occurring at one specific place, which is what? T naught, which is what? T naught, okay? So I can say that it's basically going to be infinity to minus infinity to infinity, okay? Minus infinity to infinity, and then I'm going to, so here it's going to be at one specific place, okay? So it's going to be E, that specific place, okay? One specific place. E exponent what? Minus j omega. So instead of writing t is equals to what? T naught. So I'll put what? T naught what? Over here. Okay. So basically, because the function occurs at one specific place, okay, a single specific place, it occurs as a single specific place. It's not a range like minus infinity to what? Infinity, whereby I have to what? Integrate within the interval of minus infinity to what? Infinity. I wouldn't do that. Okay. So here, basically, is just going to be equals to what? E exponent minus what? J omega what? T naught. Okay, so that is going to be what? My answer. Therefore, whenever I have any impulse function of what? T minus what? T naught like this, okay, then the Fourier transform that I'm supposed to have is going to be what? E exponent what? Minus J omega what? T naught like this. Okay, so that is what I'm supposed to get. Okay, so you move on to question number 3. Okay, so question number 3, it says, question number 3 is such that we have I. Okay, delta of what? T, delta of T plus what? T plus T naught. That is just like the former one that we just solved. So now x of what? T is equals to what? Delta of what? T plus what? T naught. Okay. So here, T is equals to what? Negative what? T naught. Okay. This signal is occurring at a specific instance of time, which is what? Minus T naught. Okay. At a single, it's occurring at a single instance of time. It's not occurring within a range. Okay. So basically, my Fourier transform of what? Delta of T plus what? T naught, okay, is supposed to be what? Even though I write minus infinity to infinity, it doesn't occur from minus infinity to infinity. It occurs at a single instance of what? Time. But for just to show you the formula, let me just write it this way. But it occurs as a single instance of what? Time minus j what? T d what? dt. So now here, what I can say is that it occurs at one specific instance of what? Time, okay? And here mostly the amplitude, this place will just be 1, okay? It will just be 1, right? So because it will just be 1, any number multiplied by 1 is what? That same number. So basically, here minus infinity to what? Infinity. Any number multiplied by 1 is that same number, because here the amplitude is 1 for unit impulse. Okay, here minus j omega what? T. Okay, the what? The t. But it doesn't occur from minus infinity to infinity. It occurs as a single instance of time. So I'll forget about these intervals I have written. And then it will be what? E exponent what? Minus occurring at what? Minus t naught. So let me put here minus what? T naught. Okay. So negative will be equals to what? E, it will become positive. E j what? T naught. Okay. So this will be what? My answer. So now now what? Let me say, okay. Now say Fourier transform, okay, of what? Delta of what? T plus what? T naught, okay, is going to be what? E exponent j what? T naught. Or you can also say that delta of what? T plus what? T naught, okay, in terms of what? Fourier or transform will give you E exponent what? J what? T naught, okay. Now let's go to the last one, okay, which is the constant amplitude. So now the constant amplitude is such that, let's say, so IV, okay, IV. So let's say the constant amplitude, let's take what? Let's take 1, okay, such that x of what? T is equals to what? 1, okay. So now from here, what we can say is that the Fourier transform. So let's say the Fourier transform of what? This one is equals to infinity minus what? Infinity. Okay, minus infinity into what? X of what? T, and into x of t. So this x of t, the minus, this one I have taken, I have to take the modulus of it because it could be negative or positive. Okay, so x of what? T, all right, into the t, okay, into the t. So what happens is that before any signal can have a Fourier transform, the integral of that signal must be what? Less than what? Infinity, as proven or as told by what? By Dirichlet what? By the Dirichlet condition. Okay, so by the Dirichlet condition. So now from here, what we can say is that infinity minus what? Infinity. Okay, so here if the signal is 1, then we can say that maybe it's a unit impulse what? Signal like this. Okay, because that is a constant amplitude also. Okay, but if I have something like this, a unit impulse function like this, and then I integrate, I'll have what? Say t, I'll have like t, I'll have t. And if I have t and I introduce in these limits, then that means that I'm going to have what? Infinity minus, okay, minus what? Infinity, okay, infinity minus infinity, which is equals to what? Which is equals to what? Infinity. So now infinity does not what? Satisfy the Dirichlet what? Condition, because the Dirichlet condition is such that it should be what? Less than what? Infinity. But right now our integral is equals to infinity. So that means that whenever I find a Fourier transform of a constant amplitude like 1 or 2 or 3, I'll have my answer to be what? Infinity, which does not satisfy the Dirichlet condition. So this one means that the Fourier transform of a constant amplitude does not exist. Okay, it does not exist. So we will use other approach to find it. We will call it what? Indirect approach. We will use indirect approach. Indirect approach. Okay, so what indirect approach are we going to use? We will use the duality property. Okay, so from the duality property, that is likened to this case, because from the duality property, we know that if x of t has a Fourier transform, okay, of x of what? Omega, okay, then x of what? T, then x of t will have a Fourier transform, okay, of what? 2 pi x x on what? Minus what? Omega. Okay, 2 pi x on minus omega. 2 pi x into minus omega. Okay, so now here we know from before that the first question that we solved in this particular lecture was finding the Fourier transform of unit impulse, which we got what 1. Okay, if you remember that we did for the delta of what t, and then we got what 1. Okay, that was question number I in this particular lecture. Okay, so this actually means that actually we can use this particular formula to find for this one. Okay, to find for this one. All right. So now here, what I can actually do is that if I have, let's say, a function, let's say this one. Okay, if I want to find the Fourier transform of this one, then the Fourier transform of this one is going, here is Fourier transform. Then the Fourier transform of this one, okay, is going to be what? It's going to be, I have to remove this t and write what? Minus what? Omega. Okay, and write minus omega times what? Times 2 pi. Okay, let me bring the 2 pi here. Okay, so basically it's going to be what? 1 into, just following this particular formula. Okay, so now in this case, I'm taking this 1 to be my what? My x of t, and then I'm taking this one to be this one. Okay, so I'm just rearranging it. So this one is the x of t, and then this one is this one. So I have 2 pi here, and then I have what? Delta of what? Minus what? Omega. Okay, so if I follow the duality principle, then I can actually have this one. All right, I can actually have this one. But this minus omega actually exists for only what? 0. Okay, exists for only 0. That means that my 1 here is Fourier transform. So that means that my 1, the Fourier transform for this one is actually going to be 2 pi into delta of what? Omega. Okay, so if I have any constant amplitude, let's say A, then the Fourier transform of A is going to be what? A what? Is going to be A 2 pi delta of what? Omega. Or you can see that A here is Fourier or transform. Okay, or you can see that Fourier or transform. You can see that 2 pi what? A into what? Delta of what? Omega. So that'll be the end of this particular session. Thank you so much.